Hello, and thanks for using TickBoom. For this video, I'll be focusing on question 10, part B, which a student has sent through. So question 10 reads, the complex number z is given by z is equal to t plus 1 on t, where t is equal to r cos theta plus I sin theta. Now we're asked to find the equation of the locus of the point P, which represents z on an Argand diagram in each of the following cases. And part B, that case tells us that theta will be pi on 4 and r will vary. So here, notice the question is saying to just find the equation of the locus, which is slightly different to a prior question, which we see in question 9, which says indicate on an Argand diagram. Now what I might do is I'll work through the question, find the equation, and then have a think about what that would look like on an Argand diagram once we get there. So to start, let's let our z equal our t plus 1 on t. That's what we're told, and that's for where t is equal to r cos theta plus I sin theta. So here we'll just use Demarva's theorem, noting that 1 on t is the same as t to the minus 1. So that's going to be r cos theta plus I sin theta plus r to the negative 1 cos negative theta plus I sin negative theta. So that's Demarva's theorem. So I'll just expand this. We'll get r cos theta plus r I sin theta plus 1 on r. Cos negative theta will become cos theta, and I sin negative theta will become negative I sin theta. So minus 1 on r I sin theta, and that's using cos of negative x equals cos of x, even functions. Sine of negative x equals negative sine x. They're odd functions. So now I group things together, and we will get r plus 1 on r cos theta plus r minus 1 on r I sin theta. And at this point we can insert our theta equals pi on 4, because remember we're told to say we want theta pi on 4. So I'll just write this. We'll go r plus 1 on r cos pi on 4 plus r minus 1 on r I sin pi on 4. And hopefully you recognize cos pi on 4 and I sin pi on 4. If I just get my calculator, if I did 180 divided by 4, 45 degrees. So if we've got a right angled triangle, and the cos is 45, then the sine will also be 45. If I just show you cos, if I did sine, we get the same number, and both of those are 1 divided by the square root of 2. So we get cos pi on 4 equals sine pi on 4 equals 1 on root 2. That's a result that you probably want to be familiar with. So now we get to our equation for the locus of z as r plus 1 on r times 1 on root 2 plus r minus 1 on r times I on root 2. So the point P would follow, would always have the coordinates r plus 1 on r times 1 on root 2. And the other coordinate would be r minus 1 on r times 1 on root 2. So as r varies, our point P will then move. Now in terms of thinking about that on an Argand diagram, we don't have to do it for this question, but just out of interest, maybe I'll just draw up a little Argand diagram here. Might have to shift up a little. Yep. So we'll go real, imaginary, and I'll just say each, here we'll go 2, 4, 6. Now, you don't actually have to plot this on an Argand diagram. It's kind of complicated. But if you did have to, the kind of approach you'd have to take would be one of simple grunt work, where you plug in values for r, see what the coordinates are, and then you simply plot them. So here we can see already that we're not going to have r is equal to 0. That will be undefined. But you could start with something like r is equal to 1. So you'd get 1 plus 1 on root 2 is 2 on root 2. So we can just go root 2, the inverse times 2, root 2, 2, inverse times 2, and you get the 1.4. And here if we put 1 in there, you get 1 minus 1, so you get 0. So we know we're going to have a point that is about 1.4 and 0. And if we had r is equal to negative 1, we'd get the opposite. We get negative 2 on root 2, and negative 1 minus 1 would be 0. So you get negative 1.4 and 0. So you know the point P will hit those 2 points. From there, it's just about doing other values. So r is equal to 2, r is equal to 3, 4, and so on. And rather than you watch me key all that in, what I did separately is I took a little shortcut and opened up Microsoft Excel and just got it to do all the calculations. And just for interest, if you are interested, the locus of this, what it looks like in the Argand diagram, and this won't be perfect, but basically the shape of it is essentially like this. Kind of like 2 sideways parabolas, which when taken together kind of almost looks like a butterfly. It's like a butterfly shape, symmetrical around this vertical axis, and also symmetrical around the horizontal axis as well. So that you don't need to worry about for this question. For this question, you could stop here to say that this is the equation for the locus as r varies. But just in case you were interested, this is the shape, and you don't actually have to take my word for it. You could go and do the work yourself if you wanted and plot out all the points and see that this is what you'll ultimately get. So hopefully you've found that helpful and you've been able to follow along there. The key with these kind of questions is it's really all going to come down to Demarva's theorem, and also using these very common trigonometric results that just come in handy so often when you're dealing with these anything to the power of -1. So yeah, there you have it. Tick boom.